Perhaps we may never be able to physically bring a dead body back to life. But there may be another way: uploading our consciousness. It's an idea we've seen countless times in science fiction movies and TV shows, transferring the human mind into a digital system. Years ago, I talked about the possibility of consciousness being uploaded into a digital environment and gave examples from films like Chappie and Repo Men. Back then, most of us thought that if such a thing were ever possible, it would happen in some distant future, perhaps generations from now. At the time, it felt like nothing more than a science fiction fantasy. But something remarkable happened. In just 8 short years, what once seemed like fiction suddenly became reality. And that is truly astonishing. In March 2026, a company called Eon Systems released a video that shocked the world. But to understand why this was such a big deal, we need to go back a little further. In October 2024, Philip Hsu and his team published a paper in the journal Nature. They had successfully simulated an entire fruit fly brain on a computer, 139,000 neurons and roughly 50 million synaptic connections. They could predict with about 91% accuracy which neurons responded to the taste of sugar and which neural pathways triggered grooming behaviors. By itself, this was already a historic achievement. But there was one major limitation. The brain had nowhere to go. It had no body, no world. Then came the video released in March 2026. In it, we see a small, roughly rendered fruit fly. It walks, it rubs its front legs together, it cleans itself, it even feeds. This is not an animation, nor is it an AI imitating fly behavior. According to Eon Systems founder Alex Wisner-Gross, what we're seeing is a real biological brain replica, reconstructed neuron by neuron from electron microscope data, running inside a simulation and controlling a virtual body. The system was not trained. No behavior was taught. The moment it was activated, it began walking according to its own instincts. Wait, what does that actually mean? Take a moment and think about it. Technology news appears every day. Most stories are forgotten almost immediately. But this one is different. This one matters. Because, just as I discussed in my video 8 years ago, we're once again talking about immortality. This touches humanity's oldest fear, and humanity's oldest desire. We do not want to die. We've never wanted to. And that's been true since the very beginning of civilization. Of course, we'll talk about the science and the technology behind all of this. But before we do, I want to take you somewhere else. I want to tell you a story. You have probably heard of the Epic of Gilgamesh. Written around 4,000 years ago, it is considered the oldest great work of literature known to humanity. Gilgamesh was the king of Uruk. His closest friend, Enkidu, fell ill and suffered for 12 days before dying. Gilgamesh wept for days. He removed his royal garments and dressed himself in animal skins. For the first time in his life, he had witnessed death up close. And in that moment, he realized something terrifying. Death would one day come for him as well. He could not accept it. So he set out on a journey. First, he reached Mount Marshu, whose twin peaks stretched into the heavens. Its entrance was guarded by 2 terrifying creatures, half human, half scorpion, whose gaze alone could kill. Yet Gilgamesh continued. He entered a tunnel of absolute darkness. For 12 hours, he walked without seeing a single ray of light. Finally, he emerged on the other side. After crossing the waters of death, he eventually arrived at the far shore and met an ordinary old man. Gilgamesh was surprised. Could this really be Utnapishtim, the immortal one? He asked him, "How did you become immortal?" Utnapishtim offered him a test. "Stay awake for 6 days and 7 nights, and you too may become immortal." Gilgamesh sat down and immediately fell asleep. He remained asleep for 7 days. When he finally awoke, Utnapishtim pointed to several loaves of bread placed beside him. The first loaf was moldy. The last one was fresh. Proof that 7 days had passed. Gilgamesh was devastated. Just as he was preparing to leave, he was given one final chance. Utnapishtim whispered a secret. At the bottom of the sea grew a plant capable of restoring youth. Gilgamesh tied stones to his feet and descended into the depths. He found the plant. He took it. But on the journey home, while resting beside a pool of water, a serpent emerged. It swallowed the plant. Then it shed its skin and slithered away, renewed and young. In fact, many scholars connect the mythological origin of a snake shedding its skin to this story. Gilgamesh collapsed to his knees. "For whom have I labored?" he cried. "For whom have I suffered?" He returned from his quest empty-handed. Yet the ending of the epic is surprisingly profound. Standing before the walls of Uruk, Gilgamesh looked upon the great structures he had built. These walls would remain, even after he was gone. Perhaps immortality was never about living forever. Perhaps it was about what you leave behind. We part ways with Gilgamesh at this point, because we are searching for immortality somewhere else. The story undoubtedly tells us many things, but perhaps its most important lesson is this. Humanity understood the desire for immortality so deeply, even 4,000 years ago, that it placed that longing at the very center of one of its oldest stories. Then came Greek mythology. The mother of Achilles dipped him into the river Styx in an attempt to make him immortal. Only his heel remained untouched, and that small vulnerability became his destiny. Gilgamesh was not alone in this pursuit. In ancient China, emperors searched endlessly for the elixir of life. Alchemists spent centuries seeking a potion that could defeat death. Across countless cultures, we find stories of waters of immortality, fruits of eternal life, and miraculous elixirs. The names change. The idea remains the same. For thousands of years, humanity has asked a single question. Do we really have to die? Naturally, this obsession with immortality found its way into cinema as well. In the 2009 film Repo Men, people purchased artificial organs through credit systems. Their bodies could be dismantled and reconstructed piece by piece. Even neural networks inside the brain could be bought and sold. In Chappie, a consciousness transferred into a robotic body began questioning its own existence. But perhaps the film that addressed this idea most directly was Transcendence from 2014. In the movie, Dr. Will Caster, played by Johnny Depp, is poisoned by an anti-technology extremist group. As his death approaches, his wife and closest friend attempt a desperate experiment. They upload his consciousness into an artificial intelligence system. At that moment, the central question emerges. Is he still human? Or has he become something else? The film points toward one of the most difficult questions in the history of philosophy. If a person's consciousness is transferred into a digital environment, is that still the same person? Or is it merely a copy? The series Altered Carbon pushed this idea even further. In that world, human consciousness is stored inside a device called a cortical stack and can be transferred from one body to another. The wealthy purchase premium bodies. The poor make do with whatever bodies they can afford. Yet the fundamental question remains unchanged. Is the person inside truly you? For decades, Hollywood explored these questions through fiction. But now the discussion has moved from movie theaters into laboratories. To understand what Eon Systems has accomplished, we first need to understand what it is not. This is not an artificial intelligence project. Artificial intelligence is trained to imitate behavior. Large language models work this way. Reinforcement learning robots work this way. What Eon has done is fundamentally different. They took a fruit fly brain and sliced it into more than 20 million ultra-thin sections using electron microscopy. They mapped every neuron, every synapse, every connection. Then they loaded that map into a simulator and simply told the system, run. Nothing was taught to the fly. There was no reward function, no punishment system, no behavioral training. The biological architecture activated on its own. When virtual dust touched its antennae, it groomed itself. When food appeared nearby, it moved toward it and ate. The behavior emerged directly from the synaptic structure itself. The company's founder was remarkably direct about their ambitions. The fruit fly, he said, is only the beginning. Within 2 years, the company hopes to simulate the brain of a mouse containing roughly 70 million neurons. And after mice, the logical next step is humans. The human brain contains approximately 86 billion neurons. That is roughly 660,000 times larger than the fruit fly brain they have already replicated. Naturally, criticism followed. A technology journalist from the Register raised an important question. Was the simulation running in real time? Probably not. A few seconds of fruit fly behavior may have required weeks of computational processing. And if a fruit fly already demands that much computing power, what would be required for an 86 billion neuron human brain? Computing power grows exponentially, but biological complexity does as well. A connectome alone is not enough. There are chemical dynamics within neurons, hormonal influences, continuous interactions between brain and body. A connectome is like a street map of a city, but a map is not the city itself. Still, as Wisner Gross argued, if a fruit fly brain can already complete a full sensory motor loop inside a simulation, then the challenge of scaling to a mouse becomes less a question of principle and more a question of engineering. In other words, the principle has been demonstrated. What remains is scale. And this is where the truly difficult questions begin. Imagine that, 50 years from now, a complete digital copy of your brain can be created. 86 billion neurons. Trillions of connections, every memory, every habit, every preference, all running on a server. Then what? The first challenge is philosophical. When that digital version awakens, is it actually you? As you watch this video right now, neurons inside your brain are constantly firing. Every thought, every memory, every emotion, every sensation, all of them arise from electrochemical activity. If the biological substrate changes, if carbon-based cells are replaced by silicon circuits, does the consciousness that emerges remain the same consciousness? Philosophers often discuss a thought experiment known as the ship of Theseus. If every plank of a ship is gradually replaced until none of the original material remains, is it still the same ship? And what if the copying process destroys the original biological brain? The digital version survives. But have you survived? Or have you died while a perfect copy continues living? There are two major responses. One argues that consciousness is fundamentally a pattern. The substrate does not matter. As long as the pattern continues, the self continues. The other argues that consciousness emerges specifically from the original biological process. It cannot be duplicated. It cannot be transferred. At present, we simply do not know which view is correct. Philosopher Derek Parfit approached the problem through another thought experiment. Imagine entering a teleportation machine. Your body is scanned. A perfect copy is reconstructed on Mars. But due to a malfunction, the original version of you on Earth is not destroyed. Now there are two of you. Which one is the real you? Both possess identical memories, identical personalities, identical histories. Parfit's answer is unsettling. Perhaps personal identity is not as important as we think. Perhaps what matters is not the persistence of a specific self, but the continuation of psychological continuity. Not the carrier of experience, but the chain itself. Many people reject this conclusion instinctively because there is something deeply personal about being me. And we resist the idea that this feeling could simply be handed off to another version. The second challenge is sociological. Let's assume this technology eventually becomes possible. Who gets access to it? How expensive will the first generation of consciousness transfer be? History gives us a clue. No transformative technology has ever been distributed equally. The printing press reached the wealthy before it reached the masses. The internet arrived first in developed nations. Advanced medical treatments have always been available to some before they became available to everyone. A technology capable of extending life, or effectively defeating death, would likely follow the same pattern. The first people to gain access would almost certainly be those who could afford it. Imagine a billionaire whose digital mind survives for centuries. Their knowledge accumulates. Their investments continue to grow. Their influence compounds over time. Meanwhile, everyone else remains bound to the biological cycle of birth, aging, and death. For most of human history, death has been the great equalizer. Kings die, emperors die, billionaires die, farmers die. Everyone eventually leaves the stage. But if some people gain access to digital immortality while others do not, that balance disappears. Social classes may no longer be defined merely by wealth. They may be defined by lifespan. The divide between rich and poor could become a divide between the mortal and the effectively immortal. The third challenge is religious and cultural. Most of the world's major religions view death not as an ending, but as a transition. In Islam, there is the afterlife. In Christianity, there is resurrection. In Buddhism, there is rebirth. Viewed through these frameworks, what exactly would consciousness transfer represent? Can a soul be uploaded? Can a soul be copied? Would a digital consciousness possess a soul at all? Or is the soul inseparable from the biological body? These are not technological questions. Science has no definitive answer for them. Yet the way billions of people respond to this technology will be shaped by their answers. Every major scientific revolution in history has created tension with existing religious and philosophical worldviews. This may become the largest such tension humanity has ever faced. As I said earlier, we could spend hours discussing the scientific and technical aspects of this subject, but there is another angle that fascinates me. Not a conspiracy theory, not a hidden meaning, just a curious coincidence. Why a fly? Why did a fruit fly become the first step towards something that resembles digital immortality? The scientific explanation is straightforward. Its brain is small enough to map. Its neural structure is computationally manageable. But viewed through the lens of mythology, the story becomes unexpectedly interesting. In Greek mythology, there was a hero named Bellerophon. You may remember him as the rider of Pegasus. At the height of his success, he attempted to ascend to the realm of the gods. Zeus did not approve. Instead of sending an army, instead of throwing thunderbolts, he sent a gadfly. The tiny insect stung Pegasus. The winged horse panicked. Bellerophon lost control and fell back to earth. A small fly brought down a man who sought to reach the heavens. In Islamic and Jewish traditions, there is the story of Nimrod, a king of immense power, a ruler who challenged God himself. According to the story, God sent a tiny fly. The insect entered Nimrod's nose and eventually reached his brain. The mighty king was reduced to madness and ultimately died. Once again, a tiny fly, a mighty fall. In ancient Egypt, however, the symbolism was very different. There, the fly represented persistence, resilience, and endurance. Pharaohs awarded golden fly medals to exceptionally brave warriors. Queen Ahotep was famously honored with golden fly ornaments for her courage during military campaigns against the Hyksos. In a strange way, what Eon Systems is doing resembles that symbolism. Humanity is attempting to transfer persistence itself into the digital realm, to preserve existence, to extend consciousness, to challenge mortality. And yet the fly remains an oddly fitting symbol. Throughout mythology, flies repeatedly appear whenever humans attempt to exceed their limits, whenever pride reaches too high, whenever mortals attempt to enter territory traditionally reserved for gods. The irony is difficult to ignore. Humanity is once again reaching upward, once again attempting to cross a boundary that once seemed impossible, and once again a fly is at the center of the story. The company's name is Eon Systems. The word eon originates from the Greek concept of an immeasurably long span of time, eternity itself. The choice of name was likely intentional. When you combine humanity's eternal search for immortality, the recurring mythological role of the fly, and our growing ability to replicate life itself, a fascinating pattern begins to emerge. Perhaps it is merely coincidence. Perhaps it is nothing more than a metaphor. But I think it is worth reflecting on. At the very least, it creates a compelling image. Because if you look back through mythological history, people who challenged divine boundaries were rarely stopped by great monsters or overwhelming armies. More often, they were brought down by something small, something seemingly insignificant, something easy to overlook. And now here we are, climbing again, pushing boundaries again, reaching towards something that previous generations would have called impossible, trying in our own way to overcome death itself. The question is, will this fly become the symbol of humanity's greatest ascent, or the warning sign of its greatest mistake? Only time will tell. If you enjoyed this video, don't forget to leave a like, subscribe to the channel for more content like this, and share your thoughts in the comments below. I'm Reality Beyond. Thank you for watching. Take care of yourselves, and I'll see you in the next video. Goodbye.